Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shahmi bin Azhar and my metric number is B0820104415. So today my group and I will talk about our presentation assignment, which is the title is Controversial Second Law of Thermodynamics in the Application of Refrigeration Systems. Okay, so let's go for the first part in this presentation. In this presentation, we will talk about the closest statement. So, what is closest statement? The closest statement of the second law of thermodynamics states that it is impossible to construct a device that operates in a cycle and produce no effect other than the transfer of heat from a cooler body to a hotter body. So there is two states in closest statement, which is the first state is heat energy transport from a high temperature body to a low temperature body in nature. And the second state is heat energy can be pushed in reverse from low temperature to high temperature if external work is applied. So basically, this article or journal is about the rejection of the closest statement in the second state. There are many thermodynamic specialists that reject the second state of the closest statement. And this paper demonstrates by a refrigeration cycle in which work is done to create the condition where heat is transferred naturally from a higher temperature to a lower temperature in accordance with the natural process. Okay, this is the introduction for our presentation. Thermodynamics is the science of energy and contract with the amount of heat transfer. It deals with equilibrium states and change from one equilibrium states to another. So from the zeroth law states that if two bodies are in thermal equilibrium with some third body, then they are also in equilibrium with each other. The first law requires that the rate of energy transfer into a system be equal to rate of increase of the energy of that system. The second law requires that heat be transferred in the direction of decreasing temperature due to the presence of temperature difference in nature and can be pushed in reverse if external work is applied. The third law states that the entropy of pure crystal at absolute zero is zero. So this is some statement from the thermodynamic specialist. The first one is from Joseph, the German mathematical physics, said that heat cannot transfer itself, pass from a colder to a hotter body. So we can see from the second one, Max Planck said that the heat falls from a higher to a lower temperature, and in other the heat transfer can take place low to high temperature body by using some external work. We also can see that Robert says that second law of thermodynamics is stated as the existence of an extensive function of state called the entropy that can only increase for an isolated system. So basically in refrigeration and air conditioning system, it is misinterpreted that heat moves from a low temperature to a high temperature reservoir, which is mean evaporator in the application of refrigeration by applying external work. The fact is the compressor is an external source which is only driving the refrigerant towards the evaporator. So the objective of this study is to highlight that it is impossible for heat energy to transfer from a low temperature body to high temperature body, even if an external source is applied. Various significant aspects of the second law of thermodynamics have been discussed by many authors, but this area has not been discussed. So we can see that many thermodynamic specialists reject this second state from the closest statement. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Farhan bin Adrus. I will explain to you about the theory of the refrigerant system. This refrigerant system has four main components, which consist of compressor, condenser, refrigerant control, and evaporator. The function of the compressor is to take the refrigerant in vapor at a low temperature and low pressure and rise it to high temperature and high pressure. For condenser, it removes heat from the refrigerant system, converts high temperature and high pressure of the refrigerant in vapor to high temperature and high pressure in liquid by removing the heat of the condensation. The function of the refrigerant control is to regulate the flow of the refrigerant by establish two pressure zones. It converts high temperature and high pressure in liquid to a low temperature and low pressure in liquid by throttling the refrigerant. Lastly, the function of the evaporator is to convert low pressure and low temperature of the refrigerant in liquid to low temperature and low pressure refrigerant in vapor by absorbing the heat of the vaporization due to temperature difference. The external sources compressor maintain two pressure zones and push the refrigerant to carry the heat energy due to temperature difference. During evaporator process, the refrigerant boiling temperature is very low and the evaporator cabinet's temperature is set at a high temperature. This creates a temperature difference and heat energy flow from evaporator cabinet to refrigerant. Therefore, heat transfer takes place from high temperature to low temperature in both process in condenser and also in evaporator. This is why it is impossible for heat energy to transfer from low pressure body to a high temperature body even if an external source is used.
Hello, my name is Muhammad Irfan. I will continue present about method and conclusion. First of all, the level refrigeration vapor compression transistor has been used for the experiment to check the means of heat transfer during the evaporator and condensing process. And then this training system consists of refrigeration component as well as instrumentation and control components. As well, the refrigeration train system is intended for use with the level heating, ventilating, and air conditioning software, which permits the real-time monitoring of the system variable. This system consists of four main components such as hermetic compressor, mechanical air-cooled condenser, refrigerant control, and air-cooled evaporator. There are also installed mechanical and electrical accessories and several temperature sensors. Next, this is a test point T1 through T7 or provide a proper temperature reading. This four main component such as hermetic compressor, mechanical air-cooled condenser, refrigerant control, and air cooler evaporator as shown in figure 03 and 04. Then the test point T1 through T7 all provide a proper temperature reading which approximately corresponds to the room temperature. This occurs because the asserted temperature transmitters are currently powered via the USB cable between the train system and the computer. The training system has run and several experimental data has been collected. It is observed that compressor as an external source is pushing the refrigerant and maintain low and high pressure zone, but heat transfer is taking place only from higher temperature to low temperature during evaporating process in the evaporator and condenser process in the condenser. Okay. This is a phase 05 T1 to T7 temperature monitoring on refrigerant cycle on lab volt. In the figure 06 T1 to T7 temperature monitoring sensor on refrigeration circle level. The subsequent refrigeration thermodynamic property data has been recorded during experiment as presented in table 0 and figure 07. It is observed that heat energy is not being pushed from low temperature to higher temperature in the evaporator. Second, heat energy is transferring from evaporator cabinet to the refrigerant as it is at very low temperature as compared to evaporator cabinet. Besides that, the compressor as an external source is only driving the refrigerant towards the evaporator and then other main parts of refrigeration system consequently. After that, the heat energy is getting transferred from higher to low temperature in condenser as ambient air is at low temperature while refrigerant temperature as condenser is high as displayed in table 02 and figure 07. Last but not least, the refrigerant effect heat absorbed in the evaporator and heat of condensation. Heat radiation in the condenser can only be possible if the heat energy flows from high temperature to low temperature as shown in table 01 and 02 using the subsequent equation 01 and 02. We can see that the simple 1 and simple 2, simple 3, simple 4, simple 5 on the T7 evaporator cabinet temperature, the sample will decrease after we doing many sample. Yeah, because if a refrigeration on heat and transfer. For the because the T7 need to absorb the heat. Okay, for the sample 1, 2, 3, 4, 5 on the TC is, we can see the sample is maintained on the TC until HRC or the rate is maintained. Okay, that's all for me. I will continue to the Shahrul for discussion. Thank you.
Assalamualaikum. My name is Muhammad Syahrul Izzat bin Muhammad Saad. My metric number is B0820103661. So now I will continue my part for this presentation, which is discussion and conclusion. The purpose of this discussion is to highlight the main point of this study, the misconception of the second law of thermodynamics, which state that heat does flow in the opposite direction from a low temperature body to high temperature body if external work is applied. In a refrigerator, during the condensation process in the condenser, the heat energy transfers from high temperature to low temperature. During the evaporation process in the evaporator, in the refrigerator, heat energy can be pushed in reverse if external work is applied. This paper reports that heat energy cannot be pushed from low temperature to higher temperature in the evaporator even if an external device is used. Refer to figure 08 and 09. The refrigerant is delivered at a very low temperature, negative 8.3 degrees Celsius, which is below the evaporator cabinet temperature, 5.9 degrees Celsius. Hence, energy transfer takes place from the high temperature region, in this case evaporator cabinet, to low temperature region, in this case refrigerant. The compressor is an external source that is only driving the refrigerant toward the evaporator. Therefore, if we want to freeze the product in the refrigerator, we will have to pass the refrigerant at a lower temperature than the evaporator cabinet temperature, which remove the heat energy from the cabinet heat transfer from high to low. In conclusion, the heat energy transport transport from high temperature body to a low temperature body in nature. Heat transfer cannot be reversed in etc. from low temperature body to a high temperature body, and this has been explained by the experiment and in the discussion session. So that's all for me. Thank you.